Dr. S. Pavithra, Assistant Professor, PG and Research Department of Mathematics, the Standard 5X Rajaratnam College for Women, Sivagasi. Today I am going to talk about a Poisson distribution. A Poisson distribution calculates the probability of a specific number of independent events occurring within the fixed interval of time, space or distance. A Poisson distribution is a discrete probability distribution, and there are several conditions applicable for Poisson distribution. An event can occur any number of times during a time period. An event can occur any number of times. That is, for example, a telephone calls received during a particular hour. Next one is an event occur independently. That is, if an event occur, it does not affect the probability of another event occurring in the same time period. So the third one is the average rate is constant. That is, the rate does not change based on time. The last one, two events cannot occur at exactly the same instant. Now we move on to the definition of Poisson distribution. If a random variable x follows a Poisson distribution with a parameter lambda which is greater than 0, then the probability of x equal to e power minus lambda power x by x factorial, where x equal to 0, 1, 2, etc. Here lambda is the mean number of occurrences. Now we move on to the properties of Poisson distribution. So the mean of Poisson distribution is E of x, which is equal to lambda, that is the number of occurrences. Here now the variance is also the number of occurrences lambda. So in Poisson distribution, mean equal to variance equal to the number of occurrences lambda. Next, the standard distribution is also root of lambda, that is the square root of number of occurrences. So next property is mode. If lambda is not an integer, mode is equal to the greatest integer less than lambda, and if lambda is an integer, then we have two modes, lambda and lambda minus 1. Next one is the additive property. The sum of independent Poisson random variable is also a Poisson random variable. So if x is a Poisson random variable associated with a number of occurrences lambda 1, and x2 is a Poisson random variable associated with a number of occurrences lambda 2, then x1 plus x2 is also a Poisson random variable with a number of occurrences lambda 1 plus lambda 2. The skewness is 1 by root of lambda, that is 1 by root of number of occurrences. Kurtosis is beta 2 equal to 3 plus 1 by lambda. So now we illustrate the Poisson distribution with some simple examples. So the problem 1 is, if the average number of accidents in a day is 2, find the probability that exactly 3 accidents occur in a day. So we have to find the probability that we have exactly 3 accidents occurs in a day. So here lambda equal to 2 and x equal to 3. That is, the number of occurrences is 2, and we have to find exactly 3 accidents occur in a day. So x equal to 3. So p of x equal to 3 is e power minus lambda. The formula is e power minus lambda power x by x factorial, that is e power minus 2 power 3 by 3 factorial, which is equal to 0.1804. Hence the probability is 0.1804. So the probability that exactly 3 accidents occurs in a day is 0.180. So the next problem is, in a call center, the average number of calls per minute is 4. Find the probability of no calls in a minute. So the average number of calls per minute is 4. We have to find the probability of no calls in a minute. Therefore, the number of occurrences is 4 and x equal to 0. So the probability formula is e power minus lambda power x by x factorial, hence e power minus 4 power 0 by 0 factorial, which is equal to 0.0183. Therefore, the probability of no calls in a minute is 0.018. So, the problem number 3 is if lambda equal to 5, find the mean and standard deviation. So, the mean is, we know that the mean is lambda, that is the number of occurrences, therefore, the mean lambda equal to 5. And the standard deviation is root lambda, that is the square root of number of occurrences, which is equal to the square root of 5, which is equal to 2.236. Next, in Poisson distribution we have many number of applications. So the Poisson distribution is mainly used to model rare independent events occurring in a fixed interval of time, area or volume. So these are the applications of Poisson distributions: number of telephone calls per minute, number of misprints per page, number of bacteria in a sample, number of accidents per day, radioactive decay. Thank you.